the guts of a Flygt triplexor alternator. It's basically a control relay for where 3 different loads are controlled by 3 different switches, but which switch controls which load isn't important, so it's basically used as a wear leveling device. This is a control logic. It's quite simple. It's just 4 different CMOS logic chips. Don't know exactly what they are because they've got bodged on supply bus bypass capacitors and input biasing resistors bodged on, along with a 555 timer. Don't know what exactly that might be being used for, and a EEPROM being used as a switching mask. A quite old school one, given that it's copyright 1979 from Intel and program at 21 volts, which is pretty old by EEPROM standards. Then there's this switch, which is used to select whether or not it's a 2-input or 3-input and a 2-load or 3-load device. Bunch of film caps. 3, although there's provisions for extra ones on the board. MID 400 optocouplers. Those are basically being used so that the control logic knows which inputs are at which states, because obviously if you're going to try and shove 120 volts AC into this stuff, it would go bang. And also that one's from 1984. That chip is from 1984, so, and it's a ceramic dill, so loads of new old stock parts when they made this thing. And the board looks quite elderly as well. Looks like it might be very early CAD, judging by the fact that everything is either orthogonal or 45 degrees. And then on the underside of the board, there is a mains transformer, a little tiny couple of volt ampere thing. That's just to supply the control logic. Lytic there, 220 degree Fahrenheit. That's Illinois capacitor, so reasonable stuff. And there's a couple transistors, most likely as drive for the 3 indicator idiot lights on the front of the thing. And another output bypass cap for the linear regulator there, and a LM340T-5, which is just a bog standard 5-volt linear regulator. And 3 relays, 1 for each output, with provisions for a 4th relay. So this most likely has a 4 output version as well. There's 4 unused pins on it, so that is feasible. And the underside of the board, complete with more bodges, says tri/quad PS, so that suggests that this does have a 4-channel variant. And that is the underside. It's basically, it plugs into a socket that comes with this thing. Like, it's, I guess, patterned after an octal socket, because the pins are the same, but they're in this pair of 6-pin rows, as well as that thing, which, little plastic spring clip, which serves both. Actually, no, I think that might be metal. Or no, I think that might be plastic, just really tough springy one. That just acts as a locator, so that, and indexer, so that this thing can only be inserted in its socket one way, and it also helps to keep it in the socket. And naturally, as I'm about to assemble the thing, one of the wires decides to break, so I just need to resolder that. And this is just a simple demo board that I built for this triplexor alternator thing. Warning, risk of electrocution, exposed, 120 volts on this thing, don't touch, bloody block can kill you. Just built this as a real simple exposed thing, just to show that there are no weird tricks involved, because I did build this for a class that I'm not going to be a TA for. Just 3 switches, 3 lights, and now of course this only changes state when switch 1 goes low. So turn it on, load 1 goes, turns on, turn it off, and it is off, and it is based on when the switch turns off. Load 2 turns on, and load 3 turns on, and of course the cycle repeats. But now, because if one switch is turned on, load 2 is going to be the one that turns on. Say, switch 2 turns on load 2, switch 3 turns on load 2. And if you turn on another switch, load 3 turns on in sequence. And you'll note that if one of the switches is on, the load that stays on switches. So see 3, 1, 2, 3, etc. So quite an interesting little tidbit, and don't know what these things go for normally. Probably north of $100, probably closer to 200. I actually should look that up, and I'm probably going to put that in the description of this video. This is a price sticker on the bottom of on the bottom of $10. I probably paid more like $5. But then again, this is got this from the same kind of place that has fuses like that, which are about $250 and change and $300 and change. Those are 2013 Granger Master Catalog prices, $5 a pop. And those are high inrush current limiting. These are RK1 class fuses, are good for 300 kiloamperes. But then again, there's probably a good few dollars worth of copper just in the end tab, so it's just a little interesting tidbit.